Hello, my name is Roger Green. I'm the founder and director of Eco Global Fuels, a company that I formed about 5 years ago to move forward a very unique and novel invention. So let's begin with what we call the Hydroxy Generators. Now this is the novel, one of the novel aspects of our technology. If you can imagine a tube 7 foot long by 6 inches wide, and inside that tube is our unique cell technology. So it's a form of electrolysis, but a little bit different, and there's a lot of innovation here. So we're based on decades of research and development. So essentially, our form of electrolysis is radically different. You might have to ask yourself, why has electrolysis never been used to be scaled up to a refinery size? They simply haven't been able to do it because conventional electrolysis uses novel metals and they use internal diaphragms, and so they're expensive to manufacture. They have high maintenance, they clog up and so forth. So our hydroxy generators essentially are robust and simple and strong and made out of cheap materials, for instance mild steel. So there's the economics of scalability here, in the sense that we can scale up thousands of and manufacture thousands of hydroxy generators, which can be conveniently stacked, very compactly stacked, to produce what we call hydroxy gas. So the input into these hydroxy generators is essentially just water and direct current electricity. And out the other end, you've got what's referred to as HHO. So we started with H2O, and now we've got HHO, which is essentially hydrogen in a more monatomic state. Now we separate the hydrogen from the oxygen in the next stage of our technology, cryogenics. Cryogenics is a known technology. And of course we've got all of the precise calculations for using cryogenics for this form of separation. So we end up with the cheapest, cleanest, most renewable hydrogen on the planet. And of course, so obviously we need a DC direct current input in running our hydroxy generators. So we've looked at scenarios involving scaling up using solar panels, and we've looked at wind, and we've also looked very carefully at using natural gas turbines, which has worked out very, very well. And we can also use waste electricity or off-peak electricity from coal power stations, because as you know, you simply can't turn off the coal power station, and at night there's a lot of wasted electricity. And in fact, we can take two negatives from the coal industry, their CO2 emissions and their waste electricity. Remember the process here: hydrogen, which we can create very, very cheaply and competitively. If you compare conventional hydrogen production, which is called the steam reformation process, it's quite expensive and it's also dirty. They emit a lot of CO2. Now our process of making hydrogen, we don't emit any CO2, and it's cost competitive. In fact, we can make it cheaper than conventional hydrogen. And hydrogen is the building blocks of all of this. So if you can make the cheapest hydrogen, all the ducks start to line up. Now, a few more other steps here. We've got hydroxy generators producing, remember, hydrogen and oxygen. So we actually have oxygen, 8 parts oxygen to 1 part hydrogen as a byproduct. That oxygen can actually be used in several scenarios. Eco Global Fuels is actually a very flexible technology, because it can bolt on to all sorts of available sources of DC inputs. So we can bolt on to an existing coal power station and basically clean up their act. We can bolt on to gas turbines, because we need the electricity. They produce a very clean source of CO2, which they don't really know what to do with. We need that. Plus our oxygen can be looped back in to what's called a pure oxy burn. A pure oxy burn into natural gas turbines, or of course coal, starts to really make those turbines a lot more efficient and the emissions are less. So instead of them sucking in all of the air, which is full of nitrogen, and the byproducts become quite toxic, we can provide them with a cheap source of oxygen. In fact, it's one of our free, if you like, byproducts of our solanol production. So we had an independent validation done on our technology last year at Macquarie University, and it cost about $100,000. And they weighed our cells before and after running our hydroxy generators for several hundred hours. So we know how much wear and tear happens on our cell technology. The degradation was precisely measured. So, and when we're running our cells, remember there's just water flowing through in a DC input, and they're made out of mild steel. Now all of that documentation is very, very carefully presented on our website here under documents. You'll see the Macquarie Validation Independent Report. You'll see our presentation that goes into all of the precise flow rates and the energy in and the energy out and so forth. So let me take you through this one more time very, very briefly. We're saying that our hydrogen is competitive, it's renewable, it's clean. Our hydroxy generators are robust, independently validated, novel. We don't use any noble metals, and the economics of scalability is there. We can scale up to a refinery size. And the facts and figures that we got from our independent validation. So there's correct and real science and chemistry and economics going on here in our presentations. Now, the next step, of course, is cryogenics. And cryogenics is a proven, known technology, and we use those quotes and those figures into our cost analysis. And our next step is to actually make a prototype demo. Is very likely to be done in Sydney, Australia. However, it's flexible. It can be built anywhere, wherever we have the financial backing and the focus. And then once we have that built, then we can then take this to the world. We can bolt it on to renewable energy sources like wind or solar, or we could build new solar farms just for this purpose, obviously on cheap arid land and in deserts and so forth. The price of solar panels are coming radically down. So there's a lot of scenarios here that eco-global fuels can lend itself to. But as I say, the next step is to get our prototype built, and that's where we would love to have your support. Now my email and my phone number is on the website, and I'm looking forward to hearing from you. Thank you very much.